So for type B of juror 1, so if juror 1 receives the message B, receives the signal B, acquittal is at least as good as conviction if the probability that the defendant is guilty given juror 1's signal is B and juror 2's signal is G, is at most Z. So the probability of the defendant being guilty, given that juror 1 receives the signal B and juror 2 receives G, is equal to the probability that juror 1 receives signal B and juror 2 G, given that the defendant is guilty, multiplied by the probability that the defendant is guilty, divided by the total probability of each juror receiving the signal that they've received. So BG times probability guilty plus probability BG, given that he's innocent, multiplied by the probability of innocence. And that is equal to 1 minus P multiplied by P times pi, divided by 1 minus P multiplied by P times pi, plus Q, 1 minus Q times 1 minus pi. So type B of juror 1 votes acquittal if Z is greater than or equal to this expression, 1 minus P times pi over 1 minus P times pi plus Q, 1 minus Q, 1 minus pi. And by the same process, type G of juror 1 votes for conviction if Z is less than or equal to P squared times pi divided by P squared times pi plus 1 minus Q squared times 1 minus pi. And we have a Nash equilibrium wherein for two jurors, the game has a Nash equilibrium where jurors vote according to their signal if Z lies within this range. And so a bit of algebra shows that the left-hand side of the inequality for two jurors is higher or larger than the left-hand side for one juror. Which is saying that the lowest value for Z for which an equilibrium exists in which each juror votes according to her signal is higher when there are two jurors. And that is because juror 1, who receives the signal B that the defendant is innocent, knowing her vote makes a difference only when juror 2 votes to convict, makes juror 1's decision on the assumption that the other juror's signal is G. Therefore, juror 1 is less worried about convicting an innocent defendant than a single juror in isolation. Okay. So what this is essentially saying is that the minimum required, so the minimum Z for conviction when it's two jurors, means that the juror 1, in order to listen to her signal, requires basically a higher probability of assurance that the defendant is in fact guilty, right? So basically a high Z means that more evidence or stronger probability to acquit given the signal is B. Right? So given the signal is B, and given that the other juror has already voted, or juror 1 is making their decision on the assumption that juror 2 has already received the guilty signal, juror 1 would need more evidence to assure him that this defendant is in fact guilty. And because the Z is high, he is less likely to vote to convict an innocent defendant. Because the Z is high, he requires a higher probability of guilt in order to convict.